So analytical geometry, we're going to start this week just by revising the grade 11 stuff because it is so important. And then we'll move on to that circle adventure from next week. Alrighty. So on your formula sheet, and I've put the formula sheet on Google Classroom, I put it up a while ago, where I also broke down the formula sheet. So what I mean by that is I said these formulas are for analytical, these for finance, blah, blah, blah. The finance formulas, and I've actually left one off here, are these in the little orange block. But like I said, because why not? I've left one off. So you have got 4 formulas you get on your formula sheet. Can anyone tell me what this formula on the left-hand side is? This formula m equals y2 minus y1 over x2 minus x1. What is it? Why do we use it? Nice, Lumelo. It is your gradient formula. So think back to straight lines. Y equals mx plus c, gradient. Just as well, question, does the layout of the formula sheet stay the same? Yes. Okay. I'm pretty sure it's been the same since even I was in school. I feel like it hasn't changed. So unless we were to bring in a whole new topic into your syllabus, it's not going to change. So what you see now in my breakdown is exactly what you'll see at the end of the year. Yeah. Okay, good. So that's your gradient. Lowercase m is your gradient. What then is the uppercase M formula? Does anyone know? Nice, Camilo, on it. Midpoint. So midpoint basically allows you to find the middle point of any line segment's gradient. The gradient of any line segment's midpoint. I don't know which is better English-wise, but you know what I mean. What is the D formula? Nice. Okay, nice Camilo, the table, very nice. It is your distance formula. So if you want the distance or the length of a line segment, you use the distance formula. What is this formula at the bottom, this tan theta formula? What does that help us find? Okay, so you definitely use the gradient here. So this is saying tan theta is equal to your gradient. What does it help you find? Nice. Okay. Nicole, I hope I'm saying that correctly. Correct me if I'm wrong. This is your angle of inclination. So angle of inclination is basically the angle created between your positive x-axis and a line segment. It's how many degrees are between, or the size of the angle between your x-axis and line segment that you're talking about. So those are your 4 analytical formulas. You do actually get the circle formula on your formula sheet, but we're not dealing with that just yet, so I'm not putting it here. We'll have a look at it when we get to circles. But these 4 formulas are your bread and butter of analytical. If you can apply these 4 formulas, you're golden. Okay, so let's have a look at some questions of how we actually do exactly that. Apply our analytical formulas. So what I've done is for today's lesson is to quite literally grade 11 past papers. And I've said this to you before. When in doubt, start with 11 past papers and then you move on to grade 12 past papers. Get your foundations right before you move on up. So 3.1 says, and it starts at question 3. Sorry, I'm just saying all the things here. Starts at question 3 because if you go to any past paper and even the grade 12 past papers, question 1 and 2 is stats, 3 and 4 sometimes 5, analytical geometry, 5 if it's not analytical, 6 sometimes 7, trig, and then the rest of your paper is Euclidean geometry. So, and I said this before, if you start going through past papers, you start to see exactly what you're going to find. You're going to see that question 1 or 2 is always this. Sometimes they even go so far as question 1 is a frequency table or an ogive, and question 2 is line of regression, okay? So the more you start to do past papers, the more you can get a feel of how the questions are going to be asked. Okay, so collinear points are points that lie on a straight line. A at -8, 0, B, x -5, x -5, -8, and C, x -14 are collinear. Calculate the value of x. My English here is shocking, so we're just going to pretend that I can't speak English. We're just going to go with it. But basically, I'm saying these 3 points are collinear. Calculate the value of x. Now, that's wonderful. What does collinear mean? What does it mean for points to be collinear? Nice one, Yankosi. Okay, so they all lie on the straight line, which means that they all have the same gradient. What that means is between any 2 points, your gradient will be the same. I really struggled to draw anything in the last lesson. So if you, this is by, let's not even draw a diagonal. This is not in any way accurate. Please just bear that in mind. You've got point A, -8, 0. Point B, x -5, -8. Cool. And point C, x -14. They are all on the same straight line. So the gradient between A and B will be exactly the same as the gradient between B and C, which will be exactly the same as the gradient between A and C. Now, you don't have to do all 3. If you work out the gradient from A to B and B to C, you're fine. If you work out A to B and A to C, you're fine, whatever. You can do all 3 if you want, but you don't have to. What you want to show, or what you know, is that the gradients are the same because those points are collinear. If the question was the other way around and it said, prove that these points are collinear, you would have to work out your gradients and show that they are equal. But in this case, I told you they are collinear, so you can automatically assume your gradients are equal. Now, the reason that's important is because you can set up an equation. You know that the gradient of AB is equal to the gradient of BC or AC, whatever you're choosing to use. That is a point, or that is a piece of information that you know is true because I told you they are collinear. So all we need to do now is use the gradient formula. Gradient formula, was just there, but gradient formula is y2 minus y1 over x2 minus x1. When you substitute in grade 12s, I could not give 2 hoots which is 0.1 and which is 0.2. As long as you keep it consistent and you're not switching, you're fine. So I'm going to say for the first gradient, so of AB, this is 0.1, no, okay, 0.1, 0.2. So the gradient of AB, y of 2 is -8 minus 0 over x minus 5 minus -8. So we can neaten that up a bit. Numerator is just -8, denominator is x plus 3, because minus 8 is plus 8. So that's the gradient of AB. If we go and work out the gradient of BC, B is already 2, so I'm now going to make C 1. So y of 2 is -8 minus y of 1 is -14 over x minus 5 minus x. So 8 minus 14 becomes 8 plus 14, which is 6 over. Okay, let's have a look at 3.2. Okay, so 3.2, this is very typical exam type question, right? Having a triangle, having some sort of 2D shape on your Cartesian plane, and then working out from there. Very typical exam question, like I said. So if we have a look at what we have been given, A at 210, B at 6, -2, and C at 0, -6 are vertices of a triangle. Points D and E are the x-intercepts of straight line AC and AB respectively. Study the diagram below and answer the questions that follow. All right, so if we just understand everything, we've been given the coordinates, that's all labeled for me. And then it said D and E are the x-intercepts. We can see that quite clearly on the diagram. They're on the x-axis. Can anyone tell me which coordinate is 0 for the x-intercepts? Which coordinate is 0 for x-intercepts? Nice, Tanda. Y. Y, not y. Y is 0. So we know that for both of these, this is an x coordinate of E and then 0, x coordinate of D and then 0. Remember, if we give you information that they are, the English has left me. If we give you information that there are x-intercepts, that's important. I don't give you useless information. I've given you that for a reason, so it's important. Right, so the first question says, calculate the coordinates of M, the midpoint of BC. So I'm telling you exactly what it is. I'm telling you exactly what to do. There's no question about it. You don't have to concern yourself about, oh, what do I need to do? I've told you it's the midpoint. That's what I want. Right, so M, I obviously, okay, it's not on here. It doesn't really matter. Here's the line BC. We're looking for its midpoint. So somewhere on the middle, we have got coordinate M. Your midpoint formula, M equals x1 plus x2 over 2, y1 plus y2 over 2. Remember, it makes no difference which coordinate is 1 and which coordinate is 2. It's the same thing. So I want you guys to go and work out what your midpoint is here. Just want to. So your formula is here. It's not great, but you know, I'm trying my absolute best. That weird little thing at the bottom of that second denominator is a 2. It's trying very hard. It's not succeeding. 2. Don't know if it got better or worse. We'll just pretend it got better. Now you don't have a line. Okay, formula given, work out your midpoint for me. What absolute chaos. Done grade 12s. Okay, so oftentimes what you'll see is that the first question is not designed to be hard. It's designed to be straightforward. We're not trying to trick you in any shape, sense, or form, as much as I know sometimes you think we are. So if I make this coordinate 1, this coordinate 2, x1, 6 plus 0 over 2, y1, negative 2 plus minus 6 or minus 6 over 2. That means our midpoint here is 6 plus 0 over 2, which is 3. Negative 2 minus 6 is negative 8 divided by 2, negative 4. Please remember it's a coordinate, so you need to have the brackets and you need to have the semicolon. But now we know that M is at negative 3. No, it's not. At 3, negative 4. Now, I've said this to you before, especially in geometry, I like to fill things in as I go along. It's up to you. Okay, I just find it easier to add information to my diagram as I go along because then I have more that I can use. 3.2.2 says calculate the length of AC, leaving your answer in simplified surd form. So basically just find the length. Sorry. If we want to work out the length of a line segment, which formula should I be using?
Hannah,
Hi.
you should use the distance formula.
Lovely. Awesome. Okay. So exactly, guys, we use the distance formula. Whenever you ask for the length or the distance between points, or if you are given a length and you're being asked to solve for an unknown, you can use the distance formula. Now, distance formula, unfortunately, is often going to result in a surd or a decimal answer. But just bear in mind, your calculator always gives you the simplest surd answer. So when it says simplified surd form, your calculator automatically gives that to you. So whatever answer your calculator gives you, write that down. If it said rounded to 2 decimal places, remember you just push ST on your calculator and then you round off that to 2 decimal places. Those are the two ways we'll ask for that answer. Okay, so your distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, guys, you don't need to remember these. They're on your formula sheet. I'm just writing them down for you so that you can get used to them. So AC is this yellow length here on the left-hand side. I want you to go work out the distance for me. And remember, simplified surd answer. Your calculator automatically gives it to you. Amazing, grade 12s, well done. Okay, so it really is just as simple as substituting in square root. Okay, apparently not, so we'll try again. Square root, doesn't matter which point is which, makes no difference. C is already labeled 0.2, so I'm going to label A 0.1. So x2 is 0 minus 2 squared plus negative 6 minus 10 squared. If you'd done it the other way around, again, it doesn't matter. The other way around would be 2 minus 0 and 10 minus minus 6, or 10 plus 6. It gives you the same answer. Either way, you end up with 2 root 65 as your simplified answer. If you want to write units, sure, but we don't care. Okay, so 2.3.2 says write down the coordinates of F if A, B, C, F is a parallelogram. Okay, so what's really important here is the order in which we give you the letters. Basically, when we label a quadrilateral, we move clockwise. So if we go clockwise, we go from A to B to C and to F, somewhere up here. That would be a parallelogram. Okay, that's a weird looking F situation, but F. There we go. Didn't get any better, but F. So the order in which we give you those letters is going to be really important for you to sort of visualize where your parallelogram is. And I would definitely, maybe a bit better than what I've done, but I would just in pencil sketch where that parallelogram, that thing is going to end up, because there are 3 different parallelograms that you can form with these 3 vertices. So the order is really important to ensure that you can see that your coordinate F should be in quadrant 2, where X is negative and where Y is positive. Okay, now guys, there are a few different ways that you can do this. You can do this by inspection because you know the properties of your parallelogram, and I'll show you how to do it by inspection in a second. I'm going to show you how to do it using formulas, because if you don't know how to do it by inspection, you're guessing. And you aren't going to get marks for your working out, but the working out I'm going to show you now will always work when you are looking for the 4th vertex of a parallelogram. So any question that asks you, find the 4th vertex or find point F of your parallelogram or point Z or whatever, if you are looking for that missing 4th vertex, the method I'm about to do will always work. You won't get marks for it, which sucks, obviously, but luckily it's not a lot of working out, but it's guaranteed 2 marks for yourself. Okay, so the way we do this with formulae is to understand the properties of a parallelogram. Can anyone tell me what's special about the diagonals of a parallelogram? There's a couple things that are special about them. Give me some of them. You can unmute yourself, you can put it in the chat. What's special about a parallelogram's diagonals? I know it's been a while since you've done this rather. Tanya Celia, amazing. Exactly, guys, they bisect each other. So what that means is these diagonals cut each other in half. You're just going to pretend that that looks beautiful. And what that means is that they have the same midpoint. So the midpoint of one diagonal is the same coordinate as the midpoint of your other diagonal. And that's what we use to work out the 4th vertex. So to do this, we use our midpoint formula. So we will work out, and based on our diagram that we've drawn here, we can see that AC is one of those diagonals. We're going to work out the midpoint of AC. So that would require me to say 2 plus 0 over 2, 10 minus 6 over 2. So the midpoint of AC is 1, 2. Nice and easy. I don't have to stress about anything. Like I said, it's a very easy calculation. What this tells me is that the midpoint of BF is also equal to 1, 2, because your diagonals of your parallelogram bisect. Parallelogram, you can abbreviate to PALM to write parallelogram as gross. Now, because you know this midpoint, you can now go and use that to calculate your missing coordinate F. We know that the coordinate of F, the x coordinate of F rather, plus the x coordinate of B, which is 6 over 2, and the y coordinate of F plus the y coordinate of 2, so negative 2 over 2, will give me that midpoint. And this midpoint formula is really nice because what you can now do is you can work with these fractions separately. So what I mean by that is we're now going to take the x fraction and make it equal to 1, because we know that that whole fraction must simplify to 1. And we can now go and say the y fraction must be equal to 2. So this is why the midpoint formula is so nice. It's because you can separate them. So this fraction must be equal to 2. And now you just go and solve for x and y. So for the x coordinate, or the x coordinate, you times 2 on both sides. So if x plus 6 equals 2, subtract 6, you get x is equal to negative 4. For the y coordinates, again, multiply both sides by 2, you get y minus 2 equals 4, plus 2 on both sides, y is equal to 6. Remember I said it's in quadrant 2, X should be negative, which it is. Y should be positive, which it is. So we have worked out that F is at -4, 6. Right, so again, unfortunately, you don't get any marks for this. You're just going to get 2 marks for your answer, but this will always work if you are looking for the 4th vertex of a parallelogram, always. So my advice is use it. Don't sit and try and figure it out and count things unnecessarily. If you are unsure, use the midpoint. Right, but I did say you could do this by inspection. So just to show you how you would do it. Chaos, okay. Just to show you how you would do it. So don't know why my words have escaped me at this moment in time, but we're going to just roll with it. Interesting, real interesting. Okay, sorry. Like I say, words escape me. It happened. So what you would need to do is you would need to work out your midpoint, but obviously you don't need to show any of your calculations. You know that the midpoint for this line is at 1, 2. Obviously nothing's writing now because why on earth would it? You know it's at 1, 2. I'm just going to scroll down so that I can actually write. And I'm going to do it in like a red color so we can see. So like I say, you would need to work out this coordinate. You know it's at 1, 2. And now you use that to quite literally just count. Okay. So from B, whatever the distance in terms of X is to your midpoint, it's the same distance on the other side. So what I mean by that is from 1 in terms of X to 6, that is 5 units. So you need to go 5 units the other way to get where F is. 5 units would take you to 1, 0. 1 unit takes you to 0, and then another 4 with the negative direction. So that gives you -4 as your X coordinate. And then you do the same thing for Y. From a Y coordinate of 2 to -2, that's a distance of 4 units down. So you need to go 4 units up now. 4 units up takes you to a Y coordinate of 6. If you have a look, that is exactly what we found F to be. So it is not necessary for you to use the midpoint. However, if you aren't comfortable with anything else, use the midpoint. It's guaranteed. You're not going to go wrong. Okay, this is a fair amount of writing. So I'm going to do screenshots at this point. Fully aware we haven't answered everything, but let's get screenshots and then we can continue. So guys, whenever you're looking for that 4th vertex, midpoint will always work. But if you can do it by inspection, clearly my brain had a brain fart and didn't want to do it by inspection. But if you'd want to do it by inspection, you need to know one midpoint, and then you just count on either side your X's, up and down your Y's, and you get your other coordinate. There's nothing wrong with that because, like I say, you actually only get 2 marks for this answer. Okay, so the next question says, show that ABCF, so the blue highlighted quadrilateral, is not a rectangle. Okay, so we know it's a parallelogram because in the question before we were told it is a parallelogram. So my question to you is, what makes a parallelogram different to a rectangle? What is a defining characteristic that a rectangle has that a parallelogram doesn't? So what does a parallelogram have? No, let's try that again. What does a rectangle have that a parallelogram does not? Nice, Leila. Exactly. Your internal angles are equal to 90 degrees. There are other Thank heavens I'm not an English teacher, because those kids would fail, right? There are other characteristics, but given the formulas you have available to you, gradient is definitely the easiest. So if you can prove that those internal angles, just one of them, is not equal to 90 degrees, you have proven it's not a rectangle. Now, the reason you can prove just one, so as long as you can prove that just one of these angles is not a right angle, is because remember, you've got a parallelogram. So if this was 90, because of parallel lines and co-interior angles, those two are co-interior, those two are co-interior, all of them would then be 90. Because we know it is a parallelogram, just proving one interior angle not equal to 90 is enough. Now, again, it really makes no difference which one you choose to go and calculate. I would probably use the line segments that I was given coordinates for. So I would not go and work out the gradient of AF and the gradient of FC just because you had to work out what F was. So if you did it wrong, it means you're carrying a wrong answer over. We do CA, but my advice is always try to use the information given to you. So I'm going to work out the gradient of AB and the gradient of BC. If I can show that those are not perpendicular, it's not a rectangle. Okay, so I'm going to give you guys 3 minutes. I want you to work out those two gradients for me, the gradient of AB and BC. If you know how to go a step further and prove that they are not perpendicular to each other, awesome. If not, we will do that in 3 minutes. So gradient of AB and the gradient of BC, please. 3 minutes. Okay, so we want some gradients. Remember, it doesn't matter which coordinate is 2 and which coordinate is 1, it doesn't matter. Now, sometimes, guys, you would have worked out this gradient already, so always just go back and double check what you have already got, because if you've already worked it out, don't do it again. So the gradient of AB, we would need to say 10 plus 2 over 2 minus 6. If you did it the other way, that's fine. But you get a gradient of negative 3. The gradient of BC is equal to minus 2 plus 6 over 6 minus 0. Again, if you did it the other way, it doesn't matter. You get the same answer. Sorry, it's not looking great. Fix that 6 in the denominator. And you get a gradient of 2 over 3. Does anyone know how I can now take those two gradients and prove that they are not at 90 degrees, or prove that they are not perpendicular? So I've got two gradients, but how do I know if they're at right angles to each other?
Ma'am?
Yeah, can you see it?
Ma'am, I don't know how to phrase it, but I think I know. You're gonna like say, since the gradients, if the gradients were like perpendicular, when you multiply them, they're supposed to give you -1. So you're supposed to do something with that.
Okay, perfect. That's exactly it. Okay, so Kanyasile said there, if your lines were perpendicular to each other, when you multiply the gradients together, you should always get -1. So that is something that we need to know. I'm pretty sure we spoke about it when we did functions, but for lines to be perpendicular, the gradient of AB times the gradient of BC must equal -1. So this is for perpendicular lines. So what you want to do is you want to go and take -3 times that by 2 over 3, and you want to see what you get. Now, obviously, that does not give you -1. And because it does not give you -1, what that means is that ABCF is not a rectangle because interior angles are not equal to 90 degrees. Okay, so that little orange bubble, really, really important to know, especially in analytical. We use a little bit in functions, but particularly in analytical geometry, when you multiply two gradients together, if you get -1, they are at right angles or they are perpendicular to each other. Okay, so that's really, really important. Alrighty. I don't think we're going to have time to do the last 3 questions. What I'll do is I'll put this at the start of the next lesson so we can finish off this question and have a look at how we would answer the rest, just because there are cool questions and there are important questions to note. So we'll finish this question off on Wednesday so you can see how you could do them. But hopefully, sorry guys, hopefully what you're noticing here is how important it is to know the properties of your quadrilaterals, but also how important it is to know the basics of what makes lines parallel, what makes lines perpendicular. And like I say, what makes a parallelogram, what makes a rectangle, etc., etc. I will find that note that I made. I know it's somewhere, and I will put it on the Google Classroom for you. So it'll summarize all of the properties of your quads. And then it will tell you exactly how to prove that certain quads are what we want them to be. So I might say, prove that this is a parallelogram, or prove that this is a rhombus, or whatever, exactly how to do that. And guys, the properties is probably the most important part. We will ask you to prove it is a specific type of shape, but that will be one question. Using the properties is really, really important. So when I eventually find that lovely thing I made, please do go through it so that you learn your properties of your quads. You have done it in grade 8, grade 9, grade 10, not really in grade 11, and now you need it again in grade 12. So it is somewhere in your mind, but please go back and revise that. Okay, so if you want to take a screenshot of this last one, by all means, like I say, I'll put it at the beginning of the next lesson to go through, and then we'll just carry on. But I will put that document up before Wednesday so that you guys have access to it for Wednesday's lesson. Okay, but I hope you have an awesome Monday evening. Enjoy school. And yeah, be back on Wednesday for our next lesson.